Hello friends, in this video I'd like to solve the following problem from the Romanian National Mathematical Olympiad for 5th graders 2023, problem number 3. We wish to find all non-negative integers m and n such that n times n plus 1 equals 3 to the power of m plus digit sum of n plus 1182. As I said, S of n stands for the digit sum of n. The sum of the digits of n in decimal system. I'd say it's a nice problem, a bit hard for my liking for 5th graders, but, well, here are my hints. First, use the fact, as it is all very often the case in these types of problems, S of n is congruent to n modulo 9. So if we sum digits of some number n in decimal system, this sum is always congruent to the number n itself, modulo 9. What are the possible quadratic residues modulo 9? Pretty easy to establish that. It may be useful along the way. And use the fact, it should be quite obvious, that sum of digits of n is somewhere between 0 and n. It's greater than or equal 0, obviously, and it's rather also obviously less than or equal n for every natural number n, to get some estimate of n. So give this problem a try, and I will see you in just a minute. Okay, so here is my solution. As I suggested, we know that for every natural number n from 0, S of n is congruent to n modulo 9, and we will use it. We'll use it. Well, so in our case, we have n squared plus n on the left-hand side is congruent to 3 to the power of m plus S of n plus 1182 modulo 9. And now let's take a look. n squared n is congruent to S of n, so we can cancel these terms. And we get n squared is congruent to 3 to the power of m. And this number, well, it's congruent to 3. It's congruent to 3 modulo 9. Pretty easy to check that. And now I wish to do a couple of things. What are the possible quadratic residues modulo 9? Well, 0 squared is obviously congruent to 0, plus minus 1 squared is congruent to 1, plus minus 2 squared is congruent to 4, plus minus 3 squared is congruent to 0, and finally plus minus 4 squared is congruent, it's 16, 16 is congruent to 7, modulo 9. So the only possible quadratic residues are 0, 1, 4, and 7. And now let's consider first case where m, this exponent right here, is greater than or equal to. If this is the case, then it should be n squared is congruent to 3 modulo 9. Because, why is that? Because 3 to the power of m is congruent to 0. This is impossible, because 3 is not in our list. Impossible. Impossible. Okay, so is it possible for m to be 1? If m were to be 1, then n squared should be congruent to 6 modulo 9. Because we have 3 plus 3. Again, 6 is not on our list, so it's impossible. Impossible. So it must be the case that now we know that m must be in fact equal to 0. And we have we have eliminated one variable. And our equation now becomes n squared plus n equals, let's take a look, 1 plus s of n plus 1182. So it's s of n plus 1183, basically. Very well, and now let's take a look. This number right here, maybe I will write it in the following way. We'll copy it. This number is obviously somewhere between sum of digits is always greater than or equal 0, and it's also every time is less than or equal n. Which means that n squared plus n is somewhere between 1183 and n plus 1183. Very well. Now let's simplify it. So this second inequality, it can be stated that n is less than or equal square root of 1183. And what about the second inequality? Well, we can write it in the following manner. 1183 plus 1/4 is less than or equal n squared plus n plus 1/4, and this is n plus 1/2 squared. So, in other words, n must be greater than or equal square root of 1183 plus 1/4 minus 1/2. Okay, and now let's do some estimation. I will use my calculator. Square root of 1183, it's approximately 34.4, let's say, while this second number, let me take a look. Well, it's somewhere or around 33.9, let's say. And now we see that the only n which is between these two numbers is 34. So it is implied at this point that n must be equal 34. But now we must do verification. We must verify it. Verification. We must compare both sides. So on the left hand side, we have n squared plus n. So we have 33 times 35. And this happens to be 1190. And on the right hand side, we have s of n plus 1183. Sum of digits of 34, 3 plus 4, well, 1190. Very well. So indeed, this is the only solution. The only, and remember m was 0. The only pair of solutions mn equals m must be 0, n must be 34. Very well, and that closes our reasoning, our video. Thank you very much for watching, I wish you a nice day, and I will see you next time. Goodbye.